Okay, so today we're here to talk about how wavelengths work. A wavelength is the distance between one crest to another. A wavelength can be found on a wave, obviously, duh. And so when you have a wavelength, it can be affected by the amplitude and the frequency. Actually, the wavelength can affect the frequency. The longer the wavelength, the lower the frequency. The shorter the wavelength, the higher the frequency. This is because when the waves occur more than one time, more than a certain number of times in one period of time, which is 1 second, is when it is determined at a frequency. So when you have more waves in one cycle, higher frequency, because that means they have to be closer together. That means your wavelength is going to be very short. And then when you have a longer one, you're gonna have a shorter, lower frequency. A couple examples of wavelengths are visible light. Red in the spectrum, in the visible light spectrum, and the electromagnetic spectrum has the longest wavelength. There are less waves per cycle, so that means it's lower frequency. For an example of a shorter wavelength is the color violet on the spectrum, and it's shorter, and that means it's less visible, a higher frequency. Another example of wavelength is the radio waves on a electromagnetic spectrum. The wavelength is much longer than the wavelength on a gamma ray, which is at the very end of the electromagnetic spectrum. That's all for wavelength.